Hi. So we're doing counting methods. We're on topic 3, the permutation formula. So our goal today is to determine the number of permutations of n objects taken at r at a time. Okay? So our first example, we're going to explore the number of ways to arrange CDs. So here's our first example. Ron has 5 different music CDs. From 5 CDs, Ron wants to place 3 in a CD disc player. We're going to use the fundamental counting principle to determine the number of ways 3 of the 5 CDs can be placed in the CD player. So using the fundamental counting principle, for the first possible CD, we can take 5. For the second possible CD, there's now only 4 left to choose from, so we get 4. And for the third possible CD, there's only 3 left to choose from. Now he's only looking for 3 CDs, out of the 5. So he's 5 different and he's placing 3 in. Okay? So we multiply these 5 times 4 times 3, and we get 60. So he has 60 different combinations. 60 different permutations that he can do there. I have to watch it because a combination is going to start to become very important when we're talking things. And this is actually a permutation. The arrangement of the CDs in the first, second, or third position of the CD player is called a permutation. So how they're arranged, it's called a permutation. Permutation is an arrangement in which order is important. Okay? And here, order is important because he wants to know the number of ways 3 of the CDs can be placed in. So he's got his first one, then his second one, and then his third one. The formula for the number of permutations of n objects taken at r at a time is as follows. And we're going to see this quite a bit. So we have this formula here. And it's the formula, we can also write it in the following way. This is what we're trying to evaluate. So basically we have 5 objects and we're picking 3. Okay? So 5 pick 3. So how do we write that? What does this mean? Well, let's write it out in terms of our factorial notation. So we have the number of objects is 5, and the r at a time is 3, because we have 3 possibilities. So we would write this out, looking at our formula, as our first number is our n, so 5 factorial over, and in the brackets below, it's 5 minus 3 factorial. So we would have 5 factorial over 2 factorial. Now, if we expanded that out, we'd get 5 times 4 times 3 times 2 times 1 over, or actually I can write that, the 2 times 1 is basically 2 factorial. So I can write that as 2 factorial over 2 factorial. So the 2 factorial divides out, and then I get what I had at in the previous answer. 5 times 4 equals 3. Or 5 times 4 times 3 equals 60. Okay? Now, here's a neat thing. We're going to talk about the calculator way later. Now, this is about understanding it, but there is some combinations on your buttons on your calculator that we can use to solve this as well. Now, we're going to continue talking about permutations. When not playing his 5 CDs, Ron stores them in a 5-slot CD case, using the fundamental counting principle to determine the number of ways of arranging 5 CDs in a 5-slot CD case. So, we're arranging. So, we have 5 to choose from in the first one, then 4, then 3, then 2, then 1. That's basically equal to 5 factorial. So you can use your calculator there, or you can multiply 5 times 4 times 3 times 2 times 1. So he has 120 different ways that he can arrange them in that CD case. The number of ways of placing 5 CDs in a 5-slot CD case is the number of permutations of 5 objects taken 5 at a time. This can be represented as 5p5. So we can write it as 5p5. Now if we put this in factorial notation, and we use that permutation formula that we looked at earlier, right, in the previous question, this is how this is going to play out, okay? 5, I really need to have it on a pen, not a highlighter. 5p5 equals, filling it into this formula here, 5 factorial over 5 minus 5, because n and r are the same thing in this case. We get 5 factorial over 0 factorial. Now here's an interesting thing. Put that in your calculator and divide, and you're going to get 120. You may say, but miss, we have a 0 on the bottom. Well, here's the thing. From the answers in part A, B, and C to be equal, what is 0 factorial equal to? Well, 0 factorial has to equal 1. And that is a little bit of a, got to remember that. So 0 factorial equals 1. Okay? And it's just how this works with factorial notation in order for these two things to be true. Okay? So this is an important thing. Let's put little stars around it so you can remember to memorize that and to remember that that is indeed how that works. Okay, let's talk a little bit more. We've done a little exploration of this with the CDs. So let's talk about what we're doing today. Now, permutation is an arrangement of distinguishable objects in which order is important. For example, 6 people can be arranged in 6 ways. Sometimes when arranging items in a group, not all of the items are needed. For instance, if there were 6 people, maybe only the number of arrangements using 4 people at one time would be needed. So sometimes we might have 6 people and we say we got 6 people on the bench, but only 4 people can be on the court at a time. What are the number of permutations of 4 people that we can have on the court? So the permutations take into consideration that we have 6 people, but we're only picking 4 of them at a time. And we use this formula right there that we've been playing around with a little bit. So it's the number of n objects taken r at a time. Okay? Best way to learn how to do something is to use it. Remember, n is the number of items, and r is the number we're using, okay, or picking. Alrighty, so let's look. Use the permutation formula to manually calculate. Use your calculator to verify your answer. So we have here 9p2. So that would be like having 9 factorial over 2 factorial, which would be like having 9 times 8 9 pick 2. Why does it have... Did you write a 7? Sorry. Sorry. It's actually... I'm not going to do it that way. We're going to use the formula. sorry, I'm going to use the formula that I just gave you. So 9p2 equals, up top we have 9, right? All over, that's why, 9 minus 2 factorial, which is the same as 9 factorial over 7 factorial. Okay? So it's this formula here is what I'm using. So, sorry, I had a little brain blip there. So that's like having 9 times 8 times 7 factorial all over 7 factorial. The 7 factorial will divide out. So if I have 9, but I pick 2, then my answer would be 9 times 8, which is equal to 72. You can use your calculator to check this. So we're going to use how to use our calculator to do a permutation. So let's look here. So to do a permutation using a TI-81 calculator, So we're going to use your calculator. So what you're going to do, take your calculator. We take this 9p2, right? We put in a 9. We pick math. And we go to PBR. Then we go down to 2 for NPR. We should already have our 9 in. And then we put in our R, which in this case is 2. And we enter. And you should get a 72. So on your screen, it should look like so. If you followed the instructions right, you would get 9. Then on your screen, it'll say 9PR and then a 2. Okay? So following those calculator instructions, that's what you should have. Okay? So you do have to enter that 9 first. Okay? Let's do the factorial. Let's use the formula to do the next one. Okay? Apparently, if you have newer models, I don't have a newer model. It's called alpha window. So you might have to look up how to do it. So if this is a newer model calculator. Okay? You might have to look up how to do your perms. Okay? So here we do the formula, 6 factorial over 6 minus 3 factorial, which is the same as 6 factorial over 3 factorial. This is like 6 times 5 times 4 times 3 factorial over 3 factorial. Those 3 factorials will divide out. So I'm left with 6 times 5 times 4, which is equal to 120. Now, I'm going to do it on my calculator. I'm going to put it in, and I want to get 6, and it'll say NPR 3. And let's see what we get there. Okay, so this is what we want it to look like in our calculator. 6, hit the math button, go to PRB, and we're taking option number 2, and then we put in a 3. And I get 120, which is the same. Okay, so that's how you use your calculator to help you solve those. So much easier. So let's keep looking. So that's how you use your calculator, and that's how you can manually calculate. So both ways are there, right? Let's do another example. Matt has downloaded 14 songs. He wants to create a playlist using only 8 songs. Use the permutation formula to determine how many 8-song playlists he's created. So let's think about what we know here. He has 14 songs, and he wants to create a playlist using only 8. Okay, so that is 14p8. Okay, now you can use your formula to do it. So it'd be 14 factorial over 14 minus 8 factorial, which is equal to 14 factorial over, well, what's 14 minus 8? It is 6. 6 factorial. So that would be 14 times 13 times 12 times 11, 10, 9, 8, 7. And that will get you your answer. Or you can put it in your calculator. It'll be 14 and it'll say NPR 8, and let's see what we get there. So 14, hit the math button, PRB, pick 2, and we want an 8. And I get, woo, it's a big number, 1, 2, 1, 0, 8, 0, 9, 6, 0. Now, if you did your 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7, I get the same number, 121,080,960. So, whichever way you do it, I know which way I like. And remember, when you get to this point, well, I mean, yeah, you got all those numbers, but isn't this down here, isn't this so much nicer because it's, you know, you're not having to worry, did I put all the right things in, that sort of thing. Okay? All right. Let's talk about some expressions. The expressions at least or at most indicate one or more than one possible outcome. So it means that there's more than one possible outcome when calculating your answer. If we have the word and, that implies multiplication. If we have the word or, that implies addition. What does that mean, Mrs. Finley? Well, let's do some examples to see exactly what I'm talking about. Alrighty. So, using 4 different colored flags, how many signals can be made consisting of 2 flags on a flagpole? So, 4 flags, but we can only pick 2. So, 4 P2, we put that in our calculator, following our instructions, and we get 12. Okay? Remember, when we look at this, it also works out if we're doing our calculations. 4 factorial over 4 minus 2 is 2 factorial. So I would get 4 times 3 times 2 factorial. Those would cancel out. 4 times 3 equals 12. So this is an or this is another option for you to do, right? Okay, they're both equal to the same thing. It's just a different way of doing it. Okay? Now, the next question says, at least 2 of the flags on a flagpole. So, we have different options. So there's different options that we can have if we have at least 2 of the flags on the flagpole. We could have 2 flags, or we could have 3 flags, or we could have 4 flags. So when we say the words at least, we have to think about what that means. Now, 2 flags we just did. It's 4P2. We have an or here, so or means plus. That's what we talked about up there, right? Or means addition. 3 flags would be 4P3. We have another or, so that would be a plus. And then we have 4 flags. Well, 4 flags would be 4P4. Okay? So let's figure those out. We can use our calculator. You can use the formula, whichever way you wish. We know this one's already 12. Plus, when we do 4P3, if you use your calculator or you do your work, you should get 24. And then 4P4, I also get 24. I add those together and I get 60. So because this says at least, we have to think about all 3 possibilities that are at least 2 of the flags on the flagpole. Okay? Let's try another example. At most 2 of the flags on a flagpole. So that's a little different situation, right? So this is at most 2 of the flags on the flagpole. So which at most might mean that it has 1 flag, or 2 flags. Okay, So for one flag, it would be 4, but we can only pick one. Plus, because it's OR, right? 4, pick 2. Now, 4P1, when you put that in, is 4. And 4P2, when you put that in, is 12. And that gives us 16. So you got to be careful. You got to listen to the language and really think. Note, to create a signal, at least one flag must appear. So you can't have 0. Alrighty? Okay. So really read the language carefully to kind of sort out the situations. Okay, I believe in that. So let's look at another one. Tariq needs to create a password for a social networking website he wants to join. The password can use any digits from 0 to 9. So 0 to 9 is 10 digits. And it must be at least 3 digits to a maximum of 5 digits. Each digit can only be used once in the password. Okay? So once he uses it, he can't use another one. Okay? So that fits our criteria. So how many passwords are possible? So let's think about it. We have 3 digits, or 4 digits, or 5 digits. Okay? 3 digits, that means he's got 10 choices, or 10 different possibilities, and he's picking only 3 of them. Now it's an OR, so it's a plus. 4 digits means he's had 10, but he's picking 4. And 5 digits, again, it's an OR, so it's a plus. 5 digits is 10, and he's picking 5. Now we figure each of these out. So 10 P 3 equals 720. 10 P4 is 5,040. Wow, you add 1 digit. That's a lot of increase of choice, right? And 10 sorry, doing my math here. 10 P5 is 3,240. Now we add those all up, and I get 36,000. So there's lots of choices for his password, right? Dun, 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 dun. Now suppose an online magazine requires each subscriber to have a password with exactly 6 digits using the same requirements as the social networking website. Which is more secure, the social networking site or the magazine website? Explain. Well, we know the amount of passwords for the social networking site. For the magazine, it's going to be 10P6. So let's figure out what that is using our calculator. So 10, put in math, PRB, pick 2, and then 6. And we're going to get, so which one's more secure? The magazine. It goes up so much more. Okay? So many more options for what your password could be, with many more passwords. Okay. All right. It just would be it'd be harder to guess. Okay. So that's your introduction to permutations. Permutations is an arrangement of objects in which distinguishable objects in which order matters. Permutation formula is based on the fundamental counting principle. The number of permutations from a set of n objects where r of them are used is calculated using this formula. Okay, now you can use that formula or you can use your calculator. To determine all possible permutations, use the following formulas. NPR if only some objects are used, and NPN or N factorial if all of the objects are used. So if all of the objects are used, you can just use your factorial. The expressions at least or at most indicate more one possible outcome. When calculating your answer, and implies multiplication or implies addition. Okay? If a counting problem has one or more conditions that must be met, consider each case separately and then add the number of ways in which each case can determine the total number of outcomes. Also, very important here, by definition, 0 factorial is equal to 1, not